Alright, time to learn about chords and arcs and circles. So we're going to look at several theorems that are going to help us out through these practice problems. But Theorem 12-4 says that if I know AOB is congruent to COD, then I know that their arcs are also going to be congruent. Okay? The converse of that, or the opposite of that, then says if I know that AB's arc is congruent to the arc of CD, so if I know my two arcs are congruent, then I can also assume that those inside angles are congruent. So I know that angle AOB is going to be congruent to angle COD. So a converse of something is basically saying it in the opposite order. Okay? So if I know the angles are congruent, then their arcs are congruent. And vice versa, if their arcs are congruent, then I know their angles are congruent as well. So that's one theorem. Another theorem says if I know that these angles are congruent, then I can draw a line between their two endpoints and make a chord, and I know their chords are congruent. So again, if I know this angle is congruent to this angle, I know that AB is congruent to CD. So the converse of that is going to be if AB is congruent to CD. So if I know my two chords are congruent, I know those interior angles are also going to be congruent. Okay? So this converse says if I know that AB is the same as CD, I know these angles are the same. So again, vice versa in that instance. All right, one more. So I've got two chords, and if I know AB is the same as CD, then I also know that their arcs are the same. Okay? The converse of that is if their arcs are congruent, then I also know that the chords are congruent. Okay? So if I know AB is congruent to CD, then I know this chord is congruent to that chord. Okay? All right. Whoop. All right. So in this diagram, I know that circle O is going to be congruent to circle P. And if I tell you that BC is congruent to DF, what all can you tell me? So based off of that information, what marks can you make? So go ahead and make those marks and write those statements. So press pause and try those. I know that their arcs are the same if I know that the chords are the same. I also know that the central angles are the same. And then what you probably forgot is if you've got two equal circles, their radiuses are going to be the same. Okay, so I said BO was the same as DP. You could have also said OC was the same as PF. Okay, so those are the things that you can determine if I tell you that two chords are congruent. Okay, so let's look at another theorem. If I know that EO is the same as FO. So if I have two chords in the circle and I have the center of the circle and I've got two radii that are hitting the chords at perpendicular angles, then I know that AB is going to be equal to CD. So I know that this piece is equal to that piece. Okay? The converse of that is also true. So if I know that AB chord is congruent to DC, so if I know my chords are congruent, I know that EO is going to be congruent to FO. So again, let me talk about that. So if I know that this chord is the same as that chord, I know that the radii that hit those at a perpendicular angle are also going to be congruent. Okay? All right. So let's look at some example problems. So I have a marking, that tells me that these are the same. Okay? And I just learned that that also tells me that those marks are the same. Okay? So if I know that this piece is 15, then I know that this whole piece is 30. And then I know x is going to be 30 because I know the chords are going to be of equal length. Okay? Same thing over here. I have a chord that if I added them together would give me 18. I have another chord that gives me 18. So if I know the chords are congruent, I know that if I have a radii that goes to the chords at a perpendicular angle, that x is also going to be 8. Okay, so that's how you're going to use that information for the chords. Let's look at another example. I know that r is 26. Okay, and then, so any radius that I draw is going to be 26. So for example, if I drew a radius there, it would be 26. If I drew a radius, for example, to that, it would be 26. Okay, so any radius that you draw in your picture would be 26. I want to find AC, and I want to find DE. Okay, so first off, if you notice, let's see, let's look for DE first. Okay, if I draw a radius and connect it at point D, I formed a right triangle. Okay, and I know the radius is 26. So this line that I drew is going to be 26. So I can find ED by using the Pythagorean theorem. Okay, because this length right here was 10. So I can say x squared plus 10 squared is going to equal my hypotenuse of 26 squared. Okay, now if I solve that and subtract 10 squared, 26 squared minus 10 squared is going to be 576. Then I'm going to square root to get x by itself. And I would get 24. Okay, so I know that ED is going to be a length of a 24. Okay, so again, you can connect a radii to make a right triangle in these instances. All right, and now I want to find AC. So if you remember, if this is 24, then I also know that this piece is going to be 24. And so 24 plus 24 to give me FD is going to be 48. And I know in my theorem that this chord is going to be congruent to this chord. So I can now find AC and say it's 48 as well. Okay? You could have also proved that and drawn another radii and known that it was 26 and had a right triangle with the side of a 10 and the length of an x. Okay? You would have done the same work again twice. Okay? So that is how you find part of a chord using that theorem. So let's look at one more theorem, and that is in a circle, a diameter or a radius that is perpendicular to a chord, it's going to bisect the chord and its arc. So what that means is the diameter. So here's my diameter, it could have been a radius. If it is hitting a chord, I know it's perpendicular, so I can make that 90-degree angle. And I also know it's going to cut in half the chord, and it's going to cut in half the arc. So if I wanted to give it like that. Okay? So let's take a look at some example problems. In this example problem, it tells me to use the Pythagorean theorem to solve for x. Okay? So notice I have a chord, and I've got my diameter. And if you go from the diameter to a chord, you're going to have a 90-degree angle hit. So I need to look at this basically small right triangle. Okay? And if that whole chord is 12, I know this piece is 6. If the whole diameter is 15, half of 15 is 7.5. So now I can solve for that little height of that triangle by doing the Pythagorean theorem. So I would have 6 squared plus x squared equals 7.5 squared. Subtract 6 squared. And then x is going to be, or x squared is going to be 20.25 about. And remember, you're typing this in the calculator and then followed by that. You can't do 7.5 minus 6 and then square your answer. Lastly, you're going to square root to get 4.5 about. So the height of that x from the radius to the chord is going to be about 4.5. Okay. All right, let's look at this problem down here. So I need to solve for x. So notice x is the radius. Okay. Now I don't have a right triangle, so I need to make a right triangle. So if I draw this little connecting line, that's a radius. I went from the center of the circle to the outside of the circle. So this is my x as well. Okay. So I'm going to ignore this piece now because I've made x into a right triangle. So now I can use the Pythagorean theorem. So if I know that whole chord is 10 or 20, I know that this little piece is 10. So now I have a right triangle with 4 squared plus 10 squared equals x squared. Okay. Now, good note would be I knew the radius wasn't a 4 because this little piece did not go all the way to the outside of the circle. So I couldn't have just said x is a 4. 4 squared is 16 plus 100 equals x squared. So it'd be 116 equals x squared square root. So my x is going to be about 10.8. Okay. So again, if you do not see a right triangle that's formed, you can make a right triangle by using that radius and moving it around. So you can totally move it right there. All right, let's look at 2 more examples and then we'll be done. So I've got a center of a circle O. So OB is my radius and I've got a chord CD. So remember, you can already go ahead and assume that CX is congruent to XD because the radius hit the chord, and that's a perpendicular, and that's a theorem we learned. So if I know the radius is 13, so this whole thing is 13, and I know CD is 24, that means I know each of those pieces would be 12, or the whole thing would be 24. All right, so if CD, so if this whole measure is 134 degrees, can I find the measure of CB? Okay, so I'm going to ignore that 13 right now. So remember that theorem, if the chords were congruent, then the arcs were congruent. So I can split 34 degrees, or 134 degrees, into 2 equal parts. And so that means it would be 67 each. So CB is going to be 67, and then BD is going to be 67 as well. Okay, so now let's go back. Remember, I know that this whole piece is 13 because that was the radius. Okay, and now I need to find OX. So I just want to find this distance right here. Okay, so let's look at a right triangle. I need to make a right triangle somewhere in here to do the Pythagorean theorem. So I'm going to connect O to D. Now if I drew a radius, I know the radius is always going to be 13. Okay, so now that is unnecessary information. And if I'm looking for this piece, OX, and I know that piece is 12 and I know the hypotenuse is 13, I can do the Pythagorean theorem. And I would say x squared plus 12x, or 12 squared, equals 13 squared. I'm going to show you guys a different way. 12 squared is 144. 13 squared is 169. Subtract 144. and you will get x squared equals 25. Square root in x would be a 5. So OX is going to be 5. Okay? So if they tell you in radius, that's basically for you to be able to draw a radius yourself to connect it to make a right triangle if you're looking for how far the origin is from part of the chord. Okay? Alright, let me know if you have any questions on that. Otherwise, we have one more. So, I've got ML is my diameter, it looks like, and that's cutting in half HK. So I'm going to go ahead and make that mark. And then look at my information. So I know our radius is 10. I'll need that in the future. And then I know the whole thing, HK is 16. So I know each piece is going to be 8. So now if I know that HL, so if I know this arc is 53 degrees, what is MK? Okay, so first off, I know that KL is also going to be 53 degrees because I know their chords are the same, so their arcs are the same. Okay, now to find MK, let's look at this like a semicircle. Okay, I know semicircles are 180 degrees, and I've already used 53. So I would do 180, take away 53, and that'll give me MK, which is 127. Okay, so that also means that HM is going to be 127 as well. So that's how you use your arc knowledge. So now let's look at finding JL. So I want to find this missing piece. Okay. So finding JL is pretty tricky. Typically we've only found from the center to J. So if I assume that W is my center, I know that this is my radius. Okay. I know that length is 10. I just don't know what X is. So what I could do is I could make another radius of a 10, and then I could solve for this piece and subtract that from 10 to give me X, because I know the whole thing of WL is your radius. So if you find this piece, you'll subtract it from 10 to get X. So let's do that. So I'm going to be looking for WJ first and do X squared plus 8 squared equals 10 squared. So I have X squared plus 64 equals 100 minus 64. So my X squared is going to equal 36, or square root, and then you would get 6. Okay, so basically WJ is going to be 6. Okay, now I know that to go from all the way here, it's 10 because the radii are 10. So that means 10 minus 6 is 4. So JL is left to be 4 units long. Okay, so you do have to think a lot about the Pythagorean theorem. You've got to think a lot about a radius, connecting it to form a right triangle, and then you've got to kind of know that these chords are the same, so their arcs are the same. So very difficult concept, but if you guys practice, you can understand it. So let me know if you have any questions. Otherwise, get started on your practice.